It is wonderful to welcome you back from our coffee hour. I don't know about you all, but now I can never say good afternoon again after watching the Will Ferrell and Ryan Reynolds movie, so I was trying to avoid that. If you haven't seen it, you should probably. With that in mind, we're going to have a lovely afternoon with our panel session with who I've already introduced, the fabulous Tracy, and she is going to be our moderator, and thank you all for participating.
Okay, make sure I. Okay, so I don't think I'm going to need this. Okay, so this time around I don't have to click. It's going to be smooth as butter. We're going to start with each panelist introducing himself. Paul gave us a name. We call ourselves the A-Team. Everybody on the panel has a first name that begins with the letter A. So, yep. So each is going to introduce himself and take about 5 minutes to explain, areas of interest, affiliation, all that good stuff. So we'll start with Amon Cadogan. I hope I didn't mangle your name.
You did great.
Okay. And then we'll just go down the line, and then we'll have a couple of questions. This is intended to be informal, interactive, and questions are taken whenever anybody is in the mood to ask a question.
Well, thank you. Yeah, so my name is Amon Cadogan. I work at the Naval Information Warfare Center in San Diego. It's part of the Department of the Navy. What I do there is I'm an engineer, and I help get end-to-end systems working as good as they can. And one component of those end-to-end systems that we have tried is SRS. I'll give a little disclaimer. I'm relatively new to the ORAN world. I've been in this industry now for about 1.5 years. Prior to this, I was a geospatial analyst, doing a bunch of mapping analysis. And so I'm interested in taking that previous experience of geographic information systems and applying that to ORAN. So we've been doing a lot of that in our field tests in San Diego. So.
Okay, next is Ashutosh Dutta, who is an AT&T alumnus, and he'll tell you all about his other bona fides.
Sure, thank you, first of all, Tracy, for inviting me, and hello, everybody. I was also here last year. It's a very interesting workshop, so I'm back again. So I work for Johns Hopkins University Applied Physics Lab as a Chief 5G strategist. I also have a second hat. I'm a professor at Computer Science Department at Johns Hopkins. Tracy said before Johns Hopkins, I've been here 6 years, 6.5. I was in AT&T Labs, before that with a startup company, and spent a lot of years in Bell Communication Research, which became Telcodia Applied Research. But I started my career at Columbia University, where I got my PhD while working. I'm also an IEEE volunteer. I'm the founding co-chair for IEEE Future Network, where Tracy was the co-chair for testbed, and we have a 5G 6G innovation testbed where I'm the co-chair right now. If you have time, please visit that. So my primary interest, obviously, I'm a strong believer of open source, and I listened to Tracy's talk today. It's so important. This workshop is so important to really accelerate the innovation and deployment. Open source acts like a catalyst. We still have to be careful how we use it. So my main interest is develop the technology, create standards, build testbed from open source, and harden it enough so it becomes deployed. Not only for the operators only, but there are other verticals where 5G and 6G can be deployed, right? Operators play a big role. We work with many of the government agencies like Department of Homeland Security. I'm personally working. They like to see how 5G, 6G can really help solve the problems. They like to see a proof of concept. And open source is the best way to build something. At APL we do that, and IEEE we are doing that. So I like to see more contribution. My interest is security, 5G security to be specific right now, but I'm also a mobility guy. Thank you.
And now we have Aloysio Pereira da Silva, who is our host as well as the director of the test bed here that double duties as an ORAN, Open Testing and Integration Center, and an Accord test bed. We called it Potomac. I forget what the acronym means.
Yeah, as Tracy mentioned, I use several RADs. One of them, I am the Commonwealth Cyber Initiative Wireless Testbed Director. The testbed is two sites. One is located here on the 3rd floor, and the another one is in Virginia Tech main campus, the outdoor testbed there. I am also a research faculty at the CE department at Virginia Tech. Today I have around 10 MS and PhD students who work on the my umbrella, mainly with prototype and proof of concept, hands-on experience, and wireless communication. Mainly focus has been ORAN so far. I also serve as a technical project manager for the National Science Foundation Power Platform. I also serve as a technical project manager for US aid for the Philippines government to deploy a use case between Danao Bajo and Manila, a ORAN-based telemedicine use case, and then I am help USAID through the Philippines government. As you can see by multiple hats that I use, my expertise and interest has been always in experimental and applicable research, mainly in test bed. Okay, I have been working test bed since my initial career and in England, UK, where I was there as a 5G portfolio management, leading some 5G trials in Bristol and across of Europe. My visions of open source is well defined as well, mainly by the fact that if I do experimental working, right, and I'm also focused on workforce development, mainly as a reference my MS and PhD students. The best way for you today to build this workforce development, advanced wireless communication, is really using open source, where you have the capability to work from the application layer to the physical layer. Because if you get today a commercial equipment, it's rare that the industry, they're gonna open for us the equipment to deploy a new solution, a new AI mechanisms, test our approach, our fundamental research, use the equipment. Then the approach that we usually do is that we build this indoor and outdoor over-the-air platform test bed that using open source platform end-to-end, okay? And we deploy our new mechanism, new algorithm, new fundamental research, and demonstrate this to a proof of concept. And then we are very keen and always demonstrate this as well for the industry partners, because they can see our capability to do things, a small proof of concept, and our capability to solve the problem that maybe they may have. And then this collaboration between the academia, the test bed, network infrastructure with industry and their government is key to create the workforce development and also to help to accelerate ORAN deployment in large scale. Thank you.
Hold on to that, because I got one. Over on the left, Adrian O'Connor with Benetel.
Thank you, Tracy. Good afternoon. So I'm one of the Europeans that are here. So I'm the CEO of Benetel. We're an Irish headquartered company. We're a very, very early player in the split 7 radio business. We came from an approach of designing femtocells for other companies, and then with the introduction of a split 7, we decided to bring our own product to market. We focus primarily on private 5G, so we have both enterprise and outdoor microcell radios. We don't offer macro radios. But we also view ourselves as the most integrated split 7 radio in the market. We have completed integrations with 15 different CU-DU combinations, which means that we've had a lot of experience. We've got quite a number of units deployed around Europe, in Japan, as well as in many, many trials across the US as well. Particular interest here, of course, is open source. We work with a variety, a spectrum of providers. And we see open source playing a very, very important role in that, and have worked with SRS and OAI for some time.
Next on the left, André Puschmann with SRS.
Yeah, thanks. Hi, I'm Andre. I'm with SRS. I'm VP Engineering at SRS. I'm also another European and also an open source believer. What I'm doing at SRS is, so I've helped developing the stack over quite some time. Now I'm really happy that we've reached the maturity level there, and I'm really excited to help our partners to really take that stack and put it into deployments. So those are test beds and future looking also for real deployments, proof of concepts, and hopefully, and that's what I'm really excited about. I think we have already a really mature system that really has the potential to change and disrupt the RAN market, to really bring open source and put that into action, into real deployments. And one example, and we've talked about this earlier today, is the actual OpenRAN testing and certification and batching activities. So we'll be one of the, we will be the first open source CUDU at the end of the year that will receive that batching, and to help to convince more and more operators, smaller ones, to run proof of concept and eventually deploy our solutions in the field. Thank you.
And last but definitely not least, Ashkan Begi, and if I mangled your last name correct.
No, both were correct. That was perfect.
Okay, thank you.
All right. Hey, everyone. My name is Ashkan Begi. I'm the founder and CEO of a startup called Coherent. I am Canadian, and I am also an open source believer. So what do we do? Our mission is to help scientists and engineers create intelligent radios. Our goal is to help them build the next generation of radios that are powered in some way with machine learning or deep learning. Currently, our focus area is on how do we give radios that already exist superpowers with deep learning. So not change the radio, not change the nature of the radio, but like add capability with deep learning. Our general focus is to produce, to give design tools, to make data sets with design models, train models, test them, and then deploy them. A lot of research on the team, a lot of interesting, like how do we make this application? How do we make this application better? And my interest here is, SRS is just a great radio target. It's just a great radio target that you can integrate deep learning with and then give it interesting functionality. So I learned about OpenRAN. There was like a OpenRAN Alliance conference that happened virtually in 2001 or 2021. That's when I first learned about OpenRAN, and then I met Andre 2 years ago or 3 years ago at GRCon, and he told me a bunch about it, and then I started thinking, okay, well we can do this, and then think about turning it into a platform for R&D. Yeah, I mean we've had SRS people or people that work with SRS on the team for 18 months now. We're working on making a platform for designing different deep learning tasks and deploying them into the RAN for the purposes of researching ways to make our RAN more useful, more capable, or to give the RAN more, more performance. Just a little bit about my overall background, my past life before this. I used to work at National Instruments. I was there for 6 years. I'm passionate about helping scientists and engineers do good science and engineering, and I mean that's what we're here to talk about today. In essence, how do we make the next generation of communication systems with OpenRAN in a way that benefits everybody?
Okay, so Ash, hold the microphone, because I'm going to ask our esteemed panelists a few questions. And Ash, you're first up, since you were last to introduce yourself. So, question number 1. What key challenges do you see R&D organizations facing when deploying OpenRAN networks and test beds?
Starting points. I think starting points is like the biggest challenge. Like where do you begin? Just kind of a little bit of my experience in first diving into telecom. I'm a tinkerer. I'm an SDR user. I'm somebody that makes test and measurement, like sells test and measurement equipment. And from my perspective, diving into the telecom world, it is a world of acronyms. It is a world of bureaucracy and complexity, and just learning how to navigate that and finding the right starting point was difficult. So the presentation you did actually today, talking about like reference designs and everything, that was awesome, because that's the kind of thing that I think that the ecosystem needs. To say you have an idea and you want to find a place to explore, like having that starting point is like an extremely valuable thing.
I like flattery, and I've actually learned from others that that's a good starting point. Andre, do you want me to restate the question?
No. So from our perspective, availability is one of the biggest issue, and this goes for hardware and for software. So for hardware, at least in the like 2-3 years ago, when we started, the availability of actual radios has been a big issue. So Benetel has always been one of the few vendors who were able to sell in small units, and this is still the case. But it was still relatively complicated to get them. This has improved over the years. So universities can actually build their, acquire units and build them their testbed if they wish so. But it's still not a commodity product, so you still can't buy that. The same goes for switching or timing equipment, so that's still an issue. So you can't really build an OpenRAN reference system without signing an NDA or talking to a sales person. And something like Ash, like a decade ago, or over a decade ago actually, like the guys at Edis Research, they've built the USRP, and that really made SDR research available to like the research community, widely available. You could buy it, and everybody's using it still to date. And that's something that hopefully changed. It got better, and it's continuing to change and get better. And on the software side, I think it's also availability issue, but a different one. So there are some components, as we already learned today, that are completely missing. In some, there's actually a good variety. So the challenge for the research community is more of a selection. So understanding the ecosystem, knowing the pros and cons of those components, and whether they're actually useful for their particular needs. And we often get requests for reference or for suggestions for software, be it the rig or be it like whatever it might be. And so we feel that this is still a challenge for researchers and for research communities if they start and to select those components.
Thank you. Adrian?
I think I'll follow some of Andre's points there. But it starts off with even the use case. What is a particular test bed or POC needing to demonstrate? That's not always well defined. People haven't thought about necessarily the architecture. I know our support team gets lots of questions. Well, what about the timing? Where can we get the right kind of timing for this? And I suppose our pet peeve that we see with people is maybe an inability to follow a user guide. So then when something is brought up incorrectly, that it doesn't work, and then the radio gets blamed. But I know the work that Paul and the team have done in SRS with the tutorial has helped significantly. But we also see requirements as well for energy use cases. How can we go and work on research in energy? And of course, when you're selling a product to the market today, it mightn't have all of the futuristic bells and whistles ready, and we need to collaborate with people to identify what features are needed when.
Thank you. And now I'm going to repeat the question for the A-team rate fielders, depending on your perspective. It's the same question. What key challenges do you see R&D organizations facing when deploying OpenRAN networks and test beds? Aloisio?
Yeah, I will base in my experience in the NSF Power program, that is large-scale city test beds, and also in my experience in building the Virginia Tech test bed. What I have observed is that build a test bed, a platform that is ORAN based, require a lot of cross-technical skills set for the personnel, from the students, that sometimes they don't have, right? Then it's very challenging as well, because several of these people that does not use to work with test bed experimental work, they does not come from the field of hands-on. Then bring together to them this hardware and software co-designer together that is needed, is mandatory when you are creating experimental test bed infrastructure. It's very hard to get them to take them from the ground. I have noted as well that the overall when you are creating a test bed infrastructure, a platform for experimentations and testing evaluations that is fully open source, you also need to make all the different open source building blocks, components that come from different teams, okay, or open source, to interoperate among of them. And it's not an easy task, right? Mainly by the fact that some open source platforms, they are still far behind and follow the 3GPP specification or follow the ORAN specification. And then when you need to put all these components together in the ORAN-based test bed, you face a lot of issues. And then it's mandatory that you need people with the right skill set to bring this piece together, to understand the code. And so far, I can share that in terms of the radio access network, we have had a very close collaboration with srsRAN team, because the main cellular stack from the CCIH test bed today have been using srsRAN. And all the understanding of the coding of the srsRAN, when we need to modify something, because it's thousands of lines of code that these folks has been working for years. And then when I onboard in my team a new student, PhD or MS students, in 6 months, it's mandatory for me that they need to start to deliver and produce. Then it's very hard for them to understand thousands of lines of code in a very short period of time. And then the way that I have found to get this is work very close with the open source team as srsRAN that help us to walk us through in some of the line of codes. And then from there we can walk by ourselves.
Thank you. Ashutosh?
Sure. I think I've been listening to all my fellow panelists. It's a very important question. Also, there are challenges. So there are opportunities and challenges. You have to look at both. There are lots of opportunities to use open source. I'll make a general statement. When I was at Belcore, we used to do this getD. I don't know if any of you have used doing routing protocol. Setting up IPv6 over Linux, doing IMS, MMD type experiment, lots of fun we had there. But fast forward now with, even when I was at AT&T, we're doing a lot of open source stuff at that point, back in 2014 through 18 or around that time. Now, in the current context, I can give you 3 examples. Since I wear 3 hats, one is Johns Hopkins Applied Physics Lab, where we have multiple projects with different government agencies. We are fond of using open source for various reasons. Sometimes, obviously, if you want to buy something from vendors, it's expensive, and you have open source, try to build a proof of concept. So that is the good part. The other part is sometimes, as many of you said, documentation, lack of support. You read something in 3GPP standards, and then you go to Open5GS, or not to be specific, or P5GC, and you see some things are not standard, are not documented or implemented. So there's a big problem, right? You have a proof of concept to, let's say, do access class barring for denial of service, and you go to an open source and see it's not implemented. So then we are kind of stuck. Either you do it yourself, or try something else, or collaborate with a vendor. My second example with IEEE 5G6 Innovation Testbed. From the very get-go, we decided it's going to be open source, so people around the world can get access. They can play around. The students can, workforce development, Logio talked about. And there also we have, Naresh used to be here, product manager, we have similar problems. Certain use cases is not supported, so we have to wait. And the third one I talk about my affiliation with Johns Hopkins University. We have a lot of students who do capstone projects, and LOG, I think you probably have similar experience. They have to have the knowledge. So open source is a good way for them to go deep dive and make changes to code and come up with new way of getting things done, right? But there is so that's a good part. But again, as Alogio said, there is a problem with documentation. If I remember in the old days, there are security issues too. Sometimes we forget about it. Open Daylight, I'm talking about 2014-15, there was a problem with external entity attack, and it was not noticed by the open source community for 6 months. Obviously they fixed it. So it is important to have people look into it. And now the Linux Foundation is taken over, right? I'm hoping the support documentation part is going well. So to summarize, it has a lot of opportunities. If you don't have enough funding, open source is a good way to start something. Lack of documentation, lack of gap between standards and actual implementation is a big problem. Workforce development to make sure the students understand the thing. Those are some of the key challenges I see. But at the same time, we need to involve the vendor community because they are the people who are actually implementing. So open source is lacking certain implementation. We have to interact with the vendor community to see how some of the gaps can be fulfilled. I'll leave it there.
Okay, thank you. Aman?
Yeah, I agree with what everyone just said, so I'm going to leave it at that. It's coming from someone who, like I said, I'm just getting into this the past year and a half. I think what comes to mind is that 5G, or this whole ORAN world tends, from my perspective, tends to lie at the intersection of RF engineering, software engineering, network engineering. So if you're there's a lot of people who are maybe good at one of those things, but in order to really fully get this whole end-to-end system working, you have to be good at, or at least proficient at, all of those things. And coming from someone who is not proficient at any of those things, it is a little bit complicated. But I do find what really helps is those tutorials that srs have put up, been fantastic. The user manual, I do try to read it occasionally from Intel, is also fantastic. But yeah, I would say the learning curve is probably the most challenging part from my perspective.
Okay, thanks. All right, question number 2. And I think this question, I think, Adrian, we're going to ask you to go first. What are the most important unmet requirements when it comes to deploying OpenRAN networks for R&D today? Because you touched upon that a little bit.
I mean, yeah, it is a more difficult question to answer, the unmet demands. I mean, one of the things that we see a lot is the fact that our product is deployed. You're getting real-world feedback in live networks coming back in, which is improving the product. In R&D environments, it's much more about a test bed. It can be looking forward to explore new ideas. Again, energy efficiency is one, but there are many, many others. And it's been able to, as a vendor, balance providing the right access to capabilities and KPIs within the radio, as well as being able to have a product that is deployed in the field carrying live traffic. So that would be my short answer on it.
Okay, Andre, you want to go next and then hand off to Ash?
Yeah, I mean, deploying something always means that you have to have something working end to end, and there's a ton of components involved there. And it's, as we've learned today, so it's for 5G end-to-end system, so it's not only the RAN, CUDU, and the RU and the core, so there's also all the orchestration, the management, and all of this. And and there are still a few components that we are completely missing. So there's simply no viable open source tested field deployed solution. So I think that is something that we have to work on. And then it's also reproducibility. So that we also talked about this earlier. So testing and batching and all of that, that's all good. But it's usually only carried out once. So I think we need to get to a point where this is, done in a reproducible manner. Maybe also in different locations. So we have those venues. So in theory, we should provide appliances that those can be reproduced elsewhere, and it shouldn't be too hard to do that. And then make sure that this batching is actually those tests are actually carried out over the entire life cycle of whatever component it is, so that once they are deployed, that we can make sure that they can receive updates and it's still maintain and maintain to be functional and performant.
Thanks. Ash?
Okay, so I'm going to interpret unmet requirements as unmet needs and unmet needs for our particular needs. It would be nice to be able to do split 7.2 on a commodity software-defined radio rather than needing to buy an off-the-shelf RU. I know certain vendors are working towards that and working towards that at a pace. So that would be something that would be pretty cool for our work. Another thing that would be helpful is, and I don't know, because we have looked into taking our wacky ideas and making them OpenRAN compliant. And there's a whole bunch of tests and things that you have to achieve, but it's very confusing. And I don't know if there's steps towards achieving what would be called OpenRAN compliance with some of the things that we're doing. So yeah, those are my two answers. But split 7.2 on USRP would be super cool. Please, NI.
And let's see. I'm going to answer this question too. I think one of the most important unmet requirements when it comes to deploying OpenRAN networks for R&D today is inadequate funding, as well as stranded lab resources that are underutilized, not used most efficiently, effectively. And same thing with expertise. We need to, share expertise and share lab resources and figure out an equitable way of getting more funding and sharing that. So, okay, let's see. Aman, you want to go next?
Sure. I guess the two things that come to mind for me would be security enhancements. Coming from a DoD perspective, that's pretty important to us. So security enhancements, and then also another unmet requirement I think is really good, thorough, detailed documentation.
Can I go? Yeah, sure. I think I was listening to Tracy. One of the things, I think most of us agreed on that, having one testbed that can provide end-to-end solution is difficult. That's why we are championing about federated testbed. I think that's one of the goal probably NTIA has. So that's one thing. Second thing is interoperability. I think Elogio, you talked about that a little bit. If you are getting open source from different places, how do you make sure they work? Third thing, I was thinking more like benchmarking, having benchmarking for a specific application. We all know, right, 5G has different KPIs. Some of the applications like virtual reality need high bandwidth, some of them low latency, some of them massive sensing. So when you're using this open source, are they optimized enough, right, to support a specific type of application? There has to be some mapping between the features of this open source and underlying application and link the KPIs. I think there should be a big study around that. I know IEEE 5G, the testbed working group. Tracy, you are the founding co-chair of that. They have come up with a benchmarking report, roadmap, that talks about some of these KPIs. I'll just leave it there. Thanks.
Thanks, Ashutosh. Aloysiu?
Yeah, I do agree with Trace regarding to the skill set. I have noted, I have participated in several panels, workshops, and I have noted that a lot of people, they talk a lot about ORAN in high level, but I don't think they are aware about the complexity of the ORAN, right? ORAN brings a lot of opportunity for us, but the whole environment is virtualized. That brings a lot of complexity as well, mainly in the managed part, because you need to have now a management building block that need to manage by itself different vendors, and you need to make sure that these vendors, they are complying with the performances for the legacy system as well, right? And they need to interoperate among of them. And I think this is this will be a big problem.
Yeah, I agree with what everybody said. Okay, are we ready for the next question? And I'm just going to ask this. Whoever wants to answer, grab the mic, answer it. Don't knock anybody off the high chair. Okay. This is a good question, and I didn't. Paul, these are your questions. I didn't make up my own because yours are so good. In your experience, how do open source OpenRAN solutions currently compare with proprietary solutions when it comes to network design, deployment, operation, research? Who wants to go first?
I can try.
Aloysiu?
Yeah, I think this is I may be wrong, but I think this is an easy question to respond from the perspective when we are doing experimental and prototype. That is very important that we use open source. As I mentioned before, commercial, they will not allow us to do nothing, right? And in these directions, there is a lot of things being specified right now, right, in the ORAN Alliance specifications, that the commercial components, when they run CU and DU, that they are still there is no compliance there. And sometimes, for example, I led today the ORAN OTIC in Washington, D.C. metro area that is hosting this in this building. And what I have observed that we have vendors that bring their components to us, and they said that it's fully complying with ORAN. And when you start to talk with them and put questions about these specifications, they don't know what you are talking about. This means that they don't have the understanding of these specifications, and they cannot understand. Then if us that have an open platform, CU, DU, ORU, that we can modify from the physical layer to the application layer, we have the deep understanding of the network the ORAN specifications also for the 3GPP. And 3GPP has been working with standards, right? 3GPP, ORAN Alliance doing specifications, but these standards and these specifications, they change along of the time as the technology evolves. But you cannot see no one, okay, validate or verify these standards and these specifications. And a good example, I have one student of mine, last year, IMS student, that he got the E2 interface specifications, and he implemented the E2 specification using software-defined radio, use srsRAN, and the goal of his thesis was to do the characterizations of denial of service attack in the E2 interface as specified by ORAN Alliance. And we had very interesting findings that we noted that the way that ORAN Alliance has specified the E2 interface, they completely deny the security piece of the E2 interface. That when E2 interface is on the attack, silent attack, storm attack, the whole network infrastructure, the radio access network, go down. This means that it doesn't matter if you have intelligent in the radio intelligent controller, because you cannot reach your radio access network, you cannot dynamic intelligent control it. Then it's very important for us we should focus on standards, yes. We should do specifications as a team, everyone together, yes. But these standards and these specifications need to be validated and verified. And the best way to do that is using testbed network infrastructure, R&D, using open source.
Totally agree. Who wants to
I'd like to comment on Elogio's thing a little bit. So you mentioned about security. That's kind of my favorite topic as well. So if let's say vendor X is building a product and they're somehow overlooking the security aspects, they have to team up with a security vendor, a security monitoring vendor, right? You talked about OpenRAN, security working group 11 doing all those. So at some time, they should not be working in silo. If they don't have security expertise, they have to collaborate with somebody else to build a product. You know, they're building a product that's a security gap. It has to be fixed. If they don't have the expertise, you know, they should work with others. The second thing I may like to comment, Elogio, so vendors, they are supposed to be experts, right? If they go to 3GPP, we don't send our students to go to 3GPP. They read their standards, and the vendors and operators, they go and they make the standards. So we expect their product to be solid proof compared to if our grad students are building something based on open source, right? I mean, that is a little bit of disparity there. So I'm expecting the product built by vendors should be more mature and future, proof compared to what our folks are doing in the lab. We can contribute back to the open source, and then vendors can look at it. And if we provide an optimization algorithm, let's say, right, we contributed back to open source, and the vendors, if they are really following it, they should try to pick it up and then optimize their product, right? So that there has to be two-way process. Yeah.
Quick, because Ash is next. Very quick.
Yeah, but I think this combination between the open source network infrastructure and the vendor work together to realize this is very important. They have the expertise in 4G LTE and 4G LTE third generation telecommunication network. But if you get these engineers, and I have found several of them already in this workshop that I attend, and you start to talk with them about virtual network functions, microservices, RIC, they don't understand what you are saying to talk with them. They have the expertise in 4G LTE, they have expertise in third, second generation, I have no doubt, much better than me. But the new technology is the new generation that is building this thing. But they also need to get to their pace, okay? They need to get updated as well. Again, we've come back to the workforce development. Workforce development is not just for the new generations that we are training, it's also for the legacy engineers, right? Because they don't understand RIC, they don't understand containers, virtual network function. They don't.
That's true. Okay, Ash?
Okay, gonna answer this as an early stage startup, and in one word, well, I'm gonna follow up, but access. Access is the big difference between proprietary and open source. So just going back 3 years, we had this idea for this 5G application that we wanted to do. We needed a 5G testbed for it. As an early stage startup that's bootstrapped, there was only 3 of us on the team trying to figure out what we wanted to do at the time. We had the option of going to a carrier and begging their R&D people to kind of give us access to one of their test beds. We had the option of going and trying to set up a private 5G network ourselves, which, go to Nokia and get them to sell you something for like $150,000, which doesn't make any sense. And the third one was rely on like the innovation ecosystem in our city, which we were lucky in that case that they had an Ericsson testbed that they offered, but like there was a whole like 8-month process of getting like onboarded onto that so that we could do the thing that we wanted to do the prototyping that we wanted to do. So like lucky that we got the third option. Took like 8 months to happen, and a whole bunch of like navigating forms and making proposals, things like that, because it's taxpayer-funded activity. And doing it with SRS, we did it for under $2,000 in less than a week. So access. And I'll break that down. So like $400 laptop, $1,000 USRP, like $400 UE, like $3 or $5 SIM card. Very cheap.
Adrian, I know you have a comment that you've been. Oh, I was going to give you this mic. Okay, go. And then Andre, you're next.
Okay. Following that passionate exchange, my answer will be much more from our perception of reality, which is from a split 7 radio vendor looking back towards the CU/DU partners we're working with. I'd like to start before I come to the point about open source. There's even a huge disparity between the quality and deliverable from many of the various commercial CU/DU providers. So it comes to first question, do you own the upper L1 yourself? Are you using a reference? Is it a complete solution, the DU plus the upper L1 integrated? That's even different across all of the different players. So I think there's a huge difference between what's being sold commercially by a variety of companies. So it's not all great, and then you've got open source. I think open source has a really important role to play. I was very interested with in Paul's presentation today when he mentioned about designing from the ground up 5G native. You know, if you've ported everything from 4G, you know, it's a poor starting point to then try and make it 5G compatible. So building from the ground up takes huge effort, but then you have a much, much better deliverable out of that. So I'm seeing now that, you know, the open source solutions are becoming much more robust and capable and able to compete with many of the commercially available sort of split 7 CU/DU combinations in the market.
Andre? And Amon, get ready. You're after Andre.
Yes, yeah, and I think like this access and transparency is also something that we actually don't have we don't even know sometimes what the other like traditional CU, or what means traditional, no, other CU/DU, commercial CU/DU vendors actually are capable of. So we, I mean, it's very difficult for us to, as a CU/DU vendor, to really get to know what the capabilities are of those platforms, because we usually don't have access to those because they're like very pricey, and then we typically don't purchase them to analyze them or to get metrics from it. And even through, to be honest, even through events like Plugfests, you don't really get details out of those when it comes to their real capabilities and where they are, still missing, because it's a filtered. The output is rather filtered. So what I think would be good is, and that's something that the O-RAN Alliance is working towards. But like all those end-to-end tests, right now they are functional, but at the end of the day, there will be performance metrics included there. And then the operators will hopefully push that there are meaningful metrics in there, so that are known to everyone, to everybody, and that can be looked at. And certain systems go through those tests, and they're actually publicly available, so we can see that. And then so maybe in the future we can actually give a proper answer. What's the difference between a closed source and a proprietary commercial solution compared to an open source CU/DU implementation? I'm obviously biased, but I think we are quite good from the feedback that we are getting from those integrations that we are running, and I'm very confident, to be honest.
Good answer. Amon?
Yeah, I think I agree with a lot of the points that have been brought up. I think the big thing when I think about a commercial system is that it's built to be stable in the way that it was designed. And so that's great if you're going to use it in that way consistently. But in my experience, if you want to go in, you want to change a certain thing, or maybe go into the logs and see what's going on, that's where I find open source is a more preferable alternative, because then when you're in a commercial system, you got to call someone, and most likely you're going to have to pay more money to get that privilege to understand more about the system that you own. And The open source is great in the fact that it's customizable, and of course, as was mentioned, is you have access.
Thank you. Now, Laura, I have a question for you. Do we have enough time for me to ask the panelists one more question, or shall we open it up to the room? Okay. The people in the room are invited to ask the panelists or direct your question to a specific member of our esteemed panel. Yes.
Gentleman, Ashok raised a good point. He said the cooperation from vendors, if open source is to go to the next level or that sort of. Are there channels that you're familiar with? If we're working on something, are there channels you're familiar with that we can utilize to go down that road for cooperation from vendors? And why would they, in fact, do it? Because if it's their bread and butter and they see something that has the potential to eat into their lunch, what would do that?
Right. I think I have little experience on that even when I was in AT&T. You start with an innovation with open source, right? Because you have access to it. And sometimes the vendor community may not have even exposure to that. Okay. So that's when, let's say I'm designing an optimization algorithm and I work with vendor X. I say, your product doesn't have it, but our grad student did an interesting algorithm and this works. It's 5 times faster than what you have. At that point, they get driven into, well, looks like, this is a good thing to opportunity. So they hire this intern as an intern or whatever, right, and start collaboration with the faculty. And at that point, they really try to find the value of open source. So we have to make a point how they make the value. Talking about eating their lunch, that's a good point. But I have seen in my, at least last 15 years, a lot of times the vendors, they take advantage of the open source to even build their product, in a different way, right? I mean, obviously there are a lot of things they have to comply with. But I have seen think about the standard DSCP. There are people who have taken open source DSCP and come up with new way of optimizing it. So they have to find a way, niche way to take advantage of the open source and build their product, which is not typically available in open source.
Other questions? Yes.
So with the growth of IoT happening, we see a lot of form factors going to eSIM, but eSIMs to be anything but open. How do you guys foresee the future of that and product test development for the eSIM future?
Everybody heard that? Who wants to go first?
So I'll give you one example from the UK. So we're involved in a number of programs, and I'll be talking about that tomorrow under the Department of Science, Innovation and Technology. And in some of those programs, the deployments, like some of our radios were deployed at a concert recently in Liverpool, and there was a QR code that would allow people to access the network on this special frequency of 3.8 to 4.2, which is the non-traditional operator spectrum in the UK. And they were able to download an eSIM to their phone and access the network that way. So there are clever ideas being approached as well. But again, my experience would be limited on the SIM side.
Any other panelists want to weigh in? More questions?
Yeah. No, let me quickly say this. Yeah, so eSIM, just from a technical perspective, it's rather transparent to us, like to the OpenRAN thing. So it's a thing between like your phone, whether it's a hard SIM or an eSIM, and the core network, and it's like the authentication of that network, of that user to the core. And it's rather complex, and you have like this certificate authority that you need to run. But there are projects and systems and people like Sysmocom in Berlin, actually out of Berlin, who are working extensively on those kind of topics, and they have I believe, also recently received, let's say, the authentication to kind of, they are able to, first of all, have an open source solution where you can self-sign your SIMs and provision them. That is sometimes not enough for public networks because phones would not connect to those because they're self-signed. So you need to kind of sign them again from a authorized and trusted CA. And that's also something that you can do. I'm not 100% familiar at which stage they are at, but that's something that they are working towards. And then what Adrian said, that's something that is actually quite cool. And I think we had similar ideas for this workshop. But it's not so easy, and it usually involves quite a few parties to get this done, and then to actually have it here and have all the phones accepting it. Because what you don't want to end up with is having everything set out, and then only a few phones work with that. So you have a few parties agreed upon to make that happen.
Any other comments from the panelists? Ishan, who is with Verizon, and I think most of you know Verizon is a partner with AT&T, Jio, and Docomo within the Accord Consortium. So do you want to address the panel in general or a specific individual?
Yes, quite similar, but thank you for Simon for this opportunity. My specific question for the respected Dr. Lucio and Dr. Satori. We are working, we know that we are working on one of the joint project, but my question is specifically how the industries and university graduate students and the master students, how we can minimize the gap between two of them and how we can share more knowledge and for especially from the industry point of view as well as from the university graduate and undergraduate students who are doing amazing work at the academic sites, but sometimes they're lacking the industry knowledge. So how we can minimize that gap if you have better idea beside that's one of the project we are working on.
I can answer a little bit, then maybe I'll give it to Elogia as well. So all my life I work in the applied research type organization. Now I'm in the academics. I see students as a great asset. Again, all the students here, kudos to you guys. Lot of good ideas come from them. When I was a grad student, I was like that too. A lot of efficiency, I should say, right? So for the industry, it is a big challenge and opportunity to interact with the right faculty. Let's say somebody in your DMTS in Verizon working on network function virtualization, network slicing. You need to figure out, you want to collaborate with, let's say, University X or Y. You need to find out which faculty. So you have to do a little bit of search. So ideally, you should have a university collaboration department, whatever. That's the must, number one, right? And they should know what are the needs, because these guys, the professors and students are working 5 years from now, what things are going to happen, right? Like IEEE is another place to look for that. So once you determine the right faculty, right, then I hope every company has a solid internship program. And I mean, at APL, we hire interns every year. So that is a good way to start the collaboration with the faculty and interns, and some of those interns become your employees. So that is a starting point. But at the same time, you can collaborate with the university applying for NSF grants, DARPA grants, things like that. I think you guys are already doing that, right? That's another way to look into the futuristic idea. So it has to be a constant collaboration. Things like this, we have academics, industry, and networking break. We talk to each other, develop some contacts, exchange business cards. That's how the relationship grows, right? You want to address that?
Yeah, just to comment on that. I think I can give a very good example that we have today in my laboratory that comes from the Accord project. And all of you guys are aware that the US government has been invested very strong in leverage, acceleration, run deployment, and commercialization in the US territory. And they trying to bring together the government, the academia, and the industry to work together. When this happens, right, is where the students mainly for this academia that has experience to work mainly experimental research, prototyping, come together with the industry and do the work together, right? Funding by the government or fund for all different agencies. A good example is the Accord project, where I am the lead of Accord project on behalf of Virginia Tech. AT&T is the prime with Verizon. And we are right now, my students is having an amazing experience because we have a Verizon engineer inside of our laboratory. We have in the daily basis Nokia engineer, Fujitsu engineer, also AT&T engineers who work side by side with my students. This means that my students have very strong experience in open source deployment to use srsRAN, the full stack of ORAN, near real-time RIC, non-real-time RIC, they know everything, right? And then now they have experience to experience this, to work together in my laboratory with the ORU from Fujitsu, the baseband unit from Nokia, side by side of the engineer. Then they are able to compare, oh, I have learned this in the open source, 3GPP, following 3GPP specification standards, and leverage discussions with the engineer that is side by side. I think this collaboration with industry in academia and towards to test bed, experimental work, I think is very valuable. It also is unquestionable.
I'm so happy to hear that, and I think you are as well. Knowledge transfer is one of the key objectives of the Accord project. We expect that your students will have, as you said, Nokia, Fujitsu, Keysight, etc., Verizon, AT&T, and we'll render ourselves obsolete because our folks will transfer the knowledge to students and they'll take the baton and move forward. They are the workforce of the future.
Yeah, and who knows, tomorrow maybe these students that is working, collaborate with you today will be your engineer inside of AT&T, inside of Verizon, Dish Networking. This for sure is gonna happen, right?
Yeah. Okay, do we have time for one more question? One more. Yeah. Okay. Yes.
We've heard all the good things and the positive sides of the open source solutions, but when it comes to security standpoint, and especially comparing those to proprietary solutions, how well is open source faring as compared to proprietary solutions when it comes to deployment in projects where security and privacy are key goals?
Excellent question. That's great last question. And I'm going to ask Andre to go first and then hand off to whoever else wants to.
Perfect. I already had the mic turned on. So, yeah. So I'm involved in open source for over 2 decades now, and it's always coming up. This question, security in open source and commercial software, and obviously there's pros and cons. But I truly believe that security by obscurity is not a good thing. So it needs to be the algorithms that bring security. Obviously, like we're in an election year in the States this year, and then there has been elections in Germany, for instance, just last couple of months. And there's always discussions about leakage and manipulation of the voting machines and all of that. And yeah, first of all, that's not an RAN question, so that is open source versus commercial software for all domains. And then discussions about releasing the code that is running on those voting terminals there in public, and why not? I mean, if that is good code, it should be no problem to release that because the algorithms that are underlying there and the key material, obviously this is not released, they should be proof enough that things are going wrong, and people are looking at that and making sure that the things are secure. And by having it open source, I mean, that's one of the key advantages of our software, of open source in general, is that people can audit it and can look at it. And then I welcome everyone to break it. And then that's the key thing. So break it and then we fix it, and that's the key. But I mean, hiding things and security by obscurity, certainly not. Sorry, I turned it off again. Sorry.
Just to gonna add to that very quickly. If you go to any hacker conference or any security conference, they will always say that the only thing that should be secure and private is the private key. Everything else should be known, but the key is the one thing that makes it secure. And that's exactly like Andre said. If the stack is private, then somebody's going to find a way to break into it. But when the code is open, it gets all sorts of scrutiny and all sorts of eyeballs on it. So I would argue that open source is more secure. It's not less secure.
I just want to, so I think I wanted to understand your question. You want to see whether open source is secure, or if I'm using open source, does it have all the security requirements that 3GPP 33501 talks about? I'm just trying to understand that.
My question is, like, from an operator perspective, one would think that if they're using proprietary software, it would be more difficult to break into as compared to an open source solution where any bad actor can just understand the code and
So protecting the open source code, okay, that's your question. I mean, the other aspects of that is the open source has all the security. If I'm going to build a network today using open source, does it have all the hooks that 3GPP defines? Does it have all the security requirement for slicing, S-Cloud, orchestration? Because all those things can be hacked. Do I have enough hooks to take care of those? In APL, we do study all of those from one of our government agencies. But now, if I'm going to use open source, am I paying enough attention to see if the open source has those hooks or not? That's a challenge for the open source community also.
Just to add here, if you check the Linux Foundation website, they have specific guidelines for security in open source, right? The question is the community for a specific open source platform, are they follow these guidelines? Because this for me is a baseline, right? And then, as Ashutosh mentioned, there is security from 3GPP. Also, there is security going on Workgroup 11 or RAN Alliance, the specification. Are these open source platforms, are they at least implement the baseline of security in their open source? This is a question mark.
All right, I get the sense that we have used up our time. Thank you. I am so grateful for the opportunity to be moderating this seriously esteemed panel. And thank you all for being a great group. So.